Okay guys, hello. This is a new episode. I think no, it's not a new episode. I think that this course is IPC144. So I think it's a new course and I need to make a resume for the coming quiz that is going to be today actually, January 17 at 8 a.m. Okay, so I'm going to do this really quick, because I need to sleep. I'm not gonna miss the quiz. Okay, so I'm just going to explain to you some notes. I'm going to open the notepad just in case I need to do something. I'm going to leave it open the Visual Studio. I did some practice. Okay. Yep. I think you can hear me. I don't know, but I'm just gonna try. Okay. So um just as a general thing, so we're now users, but we're becoming as one with the software application. So our objective in this course is to make the user happy, but also not bothering the operating system or the hardware. We need to make a balance between the user and the software and the operating system. Okay, so we need to make a clarification first, right? What's the difference between software and hardware? So software is a set of predefined instructions that defines how things work. On the other hand, we have hardware. Hardware are the physical components. Okay, for example, your appliances, your computer, your device. Those are hardware, and the software is the software. Okay, there's some terminology that I explained it before, maybe or maybe not. Okay, so I'm just going to type it right here. LU FPA. Then we have register. Then we have control unit. Then we have the decoder, and finally we have the CPU. Okay, so I'm going to explain each one. So what's the CPU? The CPU is a central processing unit. It basically runs the computer, is a general workhorse, and okay, it receives all the instructions that we request. Okay, and it executes them. The CPU executes all the instructions that we give one at a time, because they are queued. It's not all at the same time. It's one at a time. Okay. Then we have the decoder. So the decoder is like a first line of defense. Okay. It extracts the instructions from the CPU. Then it translates and decodes the instructions to make the other parts so the other parts can understand that the instruction. Okay, I'm just going to write it. Okay, so the decoder, what it does is like a translator for the control unit, for the register, or for the ALU-FPA. Okay, then the information is sent. The translated information is sent to control unit. For me, control unit is like the delivery guy. It's like USPS. It's like FedEx. It's like Canada Post. It's a delivery guy because it receives the data which isn't modified, just translated, and then it sends the information either to the register or the LAU FPA. Okay, it's it's because of that I call the control unit as a delivery guy. Okay, then we have the register. The register is also called the internal memory of the CPU, and it's the responsible of sending information to the right destination, sending data to the right destination. It can be to the LAU or it can be to the FPA. Okay, so what's the difference between LAU and FPA? LAU, okay, so the control unit sends the operators to the ALU and FPA. However, the data, the variables and the values, those go to the register. Okay, so the register knows, okay, this value I think is that, and I think it goes here. Okay, so with that being said, LAU comes from arithmetic logic unit, and it deals with simple calculations with whole numbers. On the other hand, we have the FPA, which is floating point accelerator, that deals with complex calculations. Okay, like floating point numbers that are impartial. So the register sends information to the right place. So if we have 5 and 6, then it goes to the arithmetic logic unit. But let's say that we have 5.88, then it goes to the FPA, because the arithmetic can't handle impartial numbers, it just handles whole numbers. Okay, there's a big difference. Okay, the next thing that I'm going to explain is two types of primary storage, two types of storage. We have primary storage and we have secondary storage. Okay, so the primary storage is a storage that is directly accessed by the CPU. Okay, there are two types of primary storage. We have ROM and we have RAM. What's the difference between ROM and RAM? It's kind of easy. ROM is read-only memory, whereas RAM, it's random access memory. So ROM is a primary storage meant for long-term data, long-term storage. Okay, the data that we store inside ROM is persistent, doesn't need constant power. If the system turns off, the data is still there. Yeah, and ROM, it's manufactured as a predefined set of instructions. For example, starting your computer, it's a predefined instruction, but that doesn't mean that it's unmodifiable. You can modify it only if you have a firmware. Just by firmware updates, it can modify the predefined instruction. Okay. On the other hand, we have RAM, random access memory. It's meant for short-term storage. Okay. The data is not persistent and it needs constant power to store data. If the system turns off, then the input data is lost. Okay, we need to be careful with that. And yeah, and the data is temporary. And most apps are loaded into RAM. Okay, then we have secondary storage. Secondary storage is a storage that is not directly accessed by the CPU. Okay, we here, unlike primary storage, they have lower transfer speeds with the CPU. However, they are affordable. Okay, and here we can find HDDs, we have SSDs, we have CDs, Blu-ray discs, we have peripherals such as mouse, such as keyboards, monitors, printers, etc. Okay, those are secondary storage. Okay, Then we can explain about the memory speed. Okay, the transfer speed, for example, from the CPU to the register is the fastest because it's actually almost instantly. Then we have CPU, that's the velocity with primary storage. And finally, we have CPU with secondary storage. So there's a huge difference, there's a huge gap between the speed from secondary storage to the register. Okay, and yeah, with primary storage too, I suppose. Okay, that's something to know. Okay, there are two terms that we need to deal with: software and operating system. I think we talked that before on the CPR course. But anyways, software is a set of predefined instructions, whereas an operating system is a collection of programs that can distribute resources, can manage files, and can control other programs. Okay, where is the operating system located? It's located inside RAM. And why not ROM? Because ROM is a predefined set of instructions. Okay, yeah, it has predefined instructions, and the firmware calls the ROM when you turn the system on. So the ROM is called, and the ROM turns everything on and calls the operating system, but sends the operating system to the RAM, so the RAM can load it faster since it's connected to the CPU. But the once system is turned off, then the operating system goes back to ROM. Okay, I think that's pretty clear. Then we have an app or a program which is just a file, an executable file. Okay, that can process input data and can send back output data. Okay, anyways, moving on, we have fundamental units. Okay, we have bit, we have nibble, and we have bytes. So what's a bit? A bit is the smallest unit of data. Okay, it's the smallest unit of data that is represented as binary code. Okay, which is zeros or unos, zeros or ones. Okay, and we have nibble. A nibble is a larger unit of data represented of 2 bits. No, 4 bits. And finally we have bytes, which is a much larger unit of data and equals 8 bits. Okay. Anyways, we have language. We also have language generations. So, language can be classified as low-level language and high-level language. Okay, low-level language. Here we can find machine language, and we can find assembly language. Okay, so machine language is native to the CPU process, whereas assembly language is a more readable language, but still a low-level language. And what's the difference between low-level language and high-level? Low-level languages involved with CPU stuff, and it has proprietary software. So the language is specified by the manufacturer, so it can communicate with the CPU. Then we have high level. So high level, we have third generation language. For example, C, C++, or Java. It's more readable. It has like a human communication. Okay. Then we have fourth generation language. Yeah, we have fourth generation language, which is MATLAB, SQL, or Prolog. Okay, these describe actions but doesn't explain processes, unlike C or C++. So it's more used as tools instead of the detailed descriptions. Okay. And finally, we have the fifth language generation of language, which is just AI and neural networks, which doesn't matter in this course. Anyways, so but now in this course we're focusing on C language. So what are the features of C language? One is its cross compatibility. Okay, C or C++ is C or C++ is okay. Unix, Windows, and Mac OS are written in C or C++. The second characteristic is that it's very performant. It's very powerful. It's very powerful. Okay, and it can manipulate memory easily. And finally, we have it's also specialized in high performance computing, such as gaming stuff like OpenGL or DirectX 12 or stuff like that. Okay, anyways, now we're talking about compiler. So what's a compiler? A compiler is a program that can translate text to binary code so the machine can understand it. Okay, so it goes like this. So we have our source code, right? So the source code goes to a compiler. The compiler translates the source code and creates or prepares an object file that makes the source code a binary code file, and the binary code file it's converted to an executable file that we can execute it. Okay, anyways, that's how the compiler is. And then we have the text editor. The text editor is a software or program that lets us see or type or edit text. Okay, it's included inside Notepad or Sublime Text. Okay, but a compiler plus text editor and other stuff combined can form an IDE. IDE is an integrated development environment, okay, which is a bunch of programs that gives the user some tools, and it's accessible in just one place. And that's, for example, Visual Studio, that's, for example, Xcode or Eclipse. Okay, then we have types, which is something very important. So types are so a type is a rule that defines how to store values, how to store data, okay, and which operations are admissible on those values. And it also shows or defines the number of bytes available for storing values, okay, and the number and the range of possible values. Okay, a different value means that it can store a different information, and there are four arithmetic types. Okay, so we have char, we have integer, we have float, and we have double. Okay, float, now we have double. So char, it has 1 byte, okay, and it can store 1 character and or 1 value of integer. One integer represents 4 bytes in a 32-bit environment, scan can store integer values. The float, it represents 4 bytes, but it can show or it can display floating point numbers with single precision, and double 8 bytes, and represents floating point values with double precision. Okay, then we have a constant qualifier. A constant qualifier, that's what we call constant. Okay, constant plus the variable. So what makes constant? Constant, it means that the variable cannot be changed. I mean, the value of variable, it cannot be modified. If we want to modify it, if we try to modify it, it's going to show an error. Okay. Then we have a variable. Then we have variable declaration. Okay, with variable declaration, for example, x equals 5, it means that we store this data inside this variable, but this variable, it must have a type. For example, int. Okay, it must have, but you can put it like right here, int x, then x equals 5. It must, okay, because the int sets the properties to the variable. Okay, it must, so the variable must be declared with a type. Okay, anyways, and we can have multiple declarations like integer x, or comma y, comma z, or z. Or we can put x equals 5, y equals 6, and z equals 8. Okay, stuff like that. Okay, I'm now going to explain a simple calculation how that works. So we have a keyword. With a keyword, we set an input. With the input is loaded into RAM. The RAM sends the operation to the LAU or FPA, arithmetic logic unit, or floating point accelerator. They do the calculations and send the result back to the RAM, and the RAM sends the output to a monitor or a screen, I don't know. Okay, then we have escape sequences. Escape sequences are symbols, special symbols, and there's this file that I made before. So this is a line, right? It's not going to allow us to use, for example, if I use a double quote, look, okay, it's different, it's totally different. If we want to put a double quote, we put like a backslash. Okay, so for a new line, it goes with slash, then an end. Then for backlash, if you want to put just a backlash, we put double backlash. If you want a single quote, we put just a backlash, and a double quote, we put a backlash too. Okay, then we have, okay, to minimize it. Then we have string literals. So what's a string literal? It's easy. A string literal is like a text or an expression within double quotes. So blah 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 blah, that's a string literal. Okay, and what's a scan? A scanf. A scanf is an instruction that gives a user the opportunity to set an input data thanks to an input operator. Okay, so, but it goes like this: scanf, format plus address. So now you're asking, what is format, what is address? I'm going to explain it to you. So format is format, let me see, let me remember. Okay, so a format is a string literal, like this is a string literal, that converts the entered input to that can store the entered input inside an address. Okay, or it stores to a memory. It stores to a memory. Okay, and that memory is included in the address. Okay, and it goes. And in order to do that, in order to represent like an input, we need a conversion specifier. This conversion specifier can be like percentage C, percentage D, percentage F, or percentage LF. C means to char, D means to integer, F means to float, and LF means to double. Okay, so with this conversion specifier, okay, okay, it goes with the variable, like the variables type. Okay, and it means, okay, I need you to put the value inside inside this variable. Okay, and it stores like a memory. The data is stored in memory, in the memory. Okay, then we have address. The address is basically the address of the variable. Okay, and we put it like this: the asperson plus the variable. So what does asperson mean? The asperson is the actual address. It means, okay, I need you to put this value inside this variable. Okay, and this variable, yeah, so I need you to put it in your memory. I need you to store it in your memory. Okay, but this is the address, and the address, the asperson means, okay, I'm the address of this variable. So the data is entered inside this location, not the location, not variable. This is the real location. Okay, I'm not sure if you can understand, but anyways, so that's the thing. Okay, and we also have, for example, let's say that we put something, that we put printf. That printf, it also works the same, but the format, but instead of the address we put the expression. Okay, we're not going to put the asperson because we're not looking for the address, we are looking for the expression. Okay, and the format is the same, like percentage C, percentage D, percentage F, or LF, and the expression is just the variable itself, okay. And what if it's a value with several decimals, and I just want to show just 2 decimals? And we put in the format percentage dot with a number of decimals, for example 2, plus type, which is, for example, if it's a float in number, if F, or is LF, not D, not C, because they are whole numbers. Oh well, C is just one character. Okay, so yeah, I'm just going to show you. So let's say that I'm going to create int x equals to 5. Okay, then okay, then we put scanf, then we put the format. Okay, I'm going to create first a variable, so we create a variable int y. Okay, and then we scan, enter. Okay, first we're going to printf, enter the value of y. Then we put this part. Then we scan it, scan asperson. Then if it's an integer, it's a d. Okay, we close the quotes, then we put an comma, then the %, which is the address, and y. Okay, then we hit, then we're going to printf. So it means the result is, okay, in C. Yeah, so it means, okay, C, which is equals to x plus y. Okay, so we're going to sandwich D, then comma, but instead of the %, we're just going to put Z. Okay, and that's it. Then we hit Control S5. Oh wait, what? Why does it show errors? That's interesting. Control C. Why is scanf? But what's the problem with that? This function or variable may be unsafe because you're using scanf. Why? Okay, just going to why? I think it's correct. Like, it should be correct. I don't know what's the problem. No, I don't think is the math thing. Okay, you know what? I'm just going to. Okay, let me check if that's the only problem. And now what's the problem? Scan F. Why is it a problem? Dysfunction. Okay, I'm going to copy this. Just going to close it. But I really don't know what's the problem with that. Why? Is it an error? And why? No. Okay. Just what a pain in the neck. Seriously. really don't know what the problem is. But anyways, just moving on. Yeah, just moving on. I just wanna sleep because just nuts, pure nonsense. Anyway, so we have arithmetic expressions, we have integral operands, and we have floating point operands. So integral operands comes from integer values, okay, whole numbers. So we have binary operands and unary operands. Binary operands with two operands. So we have minus, plus, we have multiplication, we have division, and we have percentage. Percentage means reminder. It means reminder. So you put a division. Básicamente. Then we have unary operands. Yeah, with unary operations, we have your positive sign and negative sign, and that's all. Then with floating point operands, you have minus, plus, multiplication, division, and no percentage, because the reminder is zero basically. Okay. Anyways, by unary operations, it's the same. That's for arithmetic expressions. So next is relational expressions, which are equals, then more than, more, minor than, or minor, or you have your exclamation point plus the equal, that means not equal, and it gives you a 0 or it gives you a 1. Then with logical expressions, you have and with aspersion, or with the line, and finally with one operand you have the exclamation point, which is it reverses. Okay. Yeah, and it gives you 1 or 0. Then Morgan's law, so you have operand and operand. Then if you want to reverse with the Morgan law, you just need to put an exclamation point, then parentheses, then your operand, then or, and your operand, and that's how you can reverse. The other things, you have shortcut assignments, binary operands, and unary operands. Yeah, so yeah, just really quickly notepad. So you have shorthand assignments, you have integral operands, and that also works for floating point operands. So you have binary operands like plus equals, or minus equals, or division equals, or multiplication equals, or percentage equals. So it goes like this, like operand, then the operator, and then the other operand. So it means, like, for example, if I say like 4, then you add 4 to the operand, and a equals to a plus 4, the previous value plus 4, that's a new value, something like that. Okay. And therefore unary operands, you have your a plus plus, or plus plus a, or a minus minus, or minus minus a. That's a postfix, that's a prefix, postfix, prefix. So what's the difference between prefix and postfix? So when you put plus plus 8, it means you increment by 1. Then when you print, it prints a plus 1. Okay, but what if I say a plus plus? It's different. So it would print just a, but you know inside your mind that a is now a plus 1. So let's say that I want to print h again, so instead of appearing just a, it would mean a plus 1. Okay. And stuff like that. I mean you'll later know it. I'm just kinda, yeah, I'm just tired. Then we have casting. Okay, casting, it means it is just converting from one type to type. For example, if you're an integer and want to change to float, then you put parentheses float, then the variable, for example minute, okay, and stuff like that. Then we have mixed type expressions, like for example if you do some multiplications with a double with a float, then the result is going to be a double because the double is higher than float and stuff like that. Okay, so it's like float, like long double, then double, then long, then float, then long, then long, then int, and short, and char. And with that, this is the lowest, this is the higher. Okay, there are two types of assignment expressions. For example, you have operand, well, not operand, variable, then another variable. So let's say that there are two types of assignment expressions. One is promoting and the next one is narrowing. So promoting means that if the left hand side is higher than the right hand side, then then the value, the variable, okay, is from this type. But let's say that this type is higher than this type, then it's going to be this type, but it's truncated. So let's say that it was this is an integer, this is a double, okay, and it's supposedly 23.4. Then like narrowing, with narrowing, it would be 23.4 but truncated, and it's and it transforms to an integer, okay, and stuff like that. So yeah, that's it. I'm just really tired, and I really don't know why the Visual Studio acted like that, but anyways, I'm just tired. Anyways, bye.